The James Webb Space Telescope, JWST, stands as one in every of humanity's maximum groundbreaking achievements, presenting an effective lens into the cosmos and revealing secrets and techniques that task our modern knowledge. This splendid tool has already exposed findings so unusual and unexpected that they force astronomers to reconsider the very origins of the universe. Ought we one day measure astronomical records in terms of earlier than Webb and after Webb? Is turning into a completely real opportunity. Our existing knowledge of the cosmos paints an awe-inspiring photo. Around 13.8 billion years ago, and severe explosion, the massive bang, unleashed the universe from a novel, infinitely dense point. Area expanded, R'lyeh cooled, and the first essential forces took form, laying down the very building blocks of galaxies, stars, and planets. This grand starting crafted the elements from which the whole thing, consisting of us, was born. However, the search to apprehend this cosmic genesis would not only deepen our clinical perspective. It confronts us with profound questions on lifestyles and our vicinity within the vast universe. Even as theories try and decipher the mysteries of this primordial second, our observations have remained restrained, confined by way of the relentless enlargement of the cosmos. To release the secrets and techniques of this distant beyond, the James Webb Space Telescope became meticulously designed to peer into the universe's infancy mere moments after the massive bang. Already, it has uncovered mysteries that baffle astronomers. Newly discovered historical galaxies task previous assumptions. Astronomers as soon as idea those early galaxies would resemble the simpler, rounded or disk shapes not unusual nowadays. Yet Webb's pics display something mind-blowing. Those primeval galaxies seem elongated, unusually shaped, even equivalent to bananas. After cautiously reading lots of those new child galaxies, Webb's observations have the capacity to revolutionize our understanding of ways galaxies shape, develop, and evolve. Those findings also shine new mild on the elusive residences of dark R'lyeh, a mysterious substance notion to include a good deal of the universe. The James Webb Area Telescope's revelations don't merely append our fashions. They beckon us into an exhilarating adventure of discovery, wherein cosmic secrets anticipate those with the braveness to discover. Adding to the intrigue is the resistance a number of those findings face. Considerably, astronomers once determined comparable oddities with the Hubble Space Telescope, hinting at pickle-shaped galaxies. Dr. Alan Dressler of Carnegie Observatories, a key parent in Webb's improvement, has voiced warning approximately these conclusions, noting the challenges in making unique measurements of remote, faint galaxies. But statistical analysis of those galaxies shows something exquisite. Instead of performing round or disc-like, as anticipated, many resemble elongated cigars or bananas. Dr. P.A., the study's lead writer, elaborates on this strangeness, noting that a lot of those galaxies display bright clusters arranged like pearls along a cosmic string. Such elongated shapes are uncommon in the Gift-day universe, but they make up about 80% of Webb's sampled early galaxies. This anomaly shows that our own Milky Way may have gone through comparable evolutionary levels, transforming from an elongated or surfboard shape to its present-day shape. The type machine devised by means of Edwin Hubble in 1926 locations galaxies into wonderful categories: elliptical, lenticular, and spiral. By the point Hubble's observations reached the 2000s, the use of statistics from the Hubble Area Telescope, astronomers had created a detailed catalog of galaxy shapes from the sunrise of time to today. Their findings discovered something surprising. 6 billion years in the past, galaxies were massively specific, with unusual shapes dominating the cosmos. It regarded that, during the last 6 billion years, those strange galaxies progressively converted into the spirals we apprehend these days. This variation probably worried common galaxy mergers, a cosmic dance that appears to have persisted longer than formerly conceived. Enter the James Webb Area Telescope, which has propelled our cosmology into a brand new technology. Its discoveries venture the belief that galaxies evolved progressively from primordial hydrogen and helium clouds. Instead, it reveals that many early galaxies shaped into complicated shapes, together with spirals, an awful lot sooner than predicted. In line with Webb's facts, about a fifth of galaxies at 11.5 billion years vintage, just 2 billion years after the Large Bang, are already spirals. This rapid evolution indicates that elements beyond mere collisions may additionally have motivated the formation of those shapes. The universe has long held its secrets and techniques close. However, Webb's capabilities now permit us to see further than ever. This mind-blowing telescope has diagnosed galaxies with putting traits and raised profound questions about our information of the universe. May want our cosmos be much older than we imagined? Or possibly, as some advise, our universe is one in every of many in a giant chain, or maybe one without a real beginning. A few scientists now discover the concept of conformal cyclic cosmology, CCC, a model suggesting that our universe has experienced countless rebirths. Nobel laureate Dr. Roger Penrose theorizes that black holes from a preceding eon evaporated and sparked the subsequent Big Bang, imparting a compelling cause of the mysterious supermassive black holes seen in Webb's pics. The James Webb Area Telescope is rewriting our cosmic records, putting report after document, including the discovery of the most distant galaxy protocluster, red supergiant, and quasar ever located. These revelations endorse that our universe's age is probably a ways older than we once believed. As we contemplate whether our cosmos is everlasting or a part of a complex, interconnected chain of universes, Webb's observations hint at limitless opportunities. Possibly the Big Bang become less a unique origin and greater a defining second in an everlasting, ever-evolving cosmos. The James Webb Area Telescope, JWST, has surely revolutionized our view of the cosmos, turning the highlight on questions that had been once simply philosophical musings. For years, astronomers and cosmologists adhered to the framework of the huge bang idea, a version that provided a coherent timeline of cosmic history. In line with this version, the universe multiplied from an infinitely hot, dense factor kind of 13.8 billion years ago, cooling over the years and subsequently giving upward push to the galaxies, stars, and planets we look at nowadays. However, Webb's discoveries are challenging these assumptions, revealing a cosmos some distance more complex and likely some distance older than we ever imagined. At the heart of Webb's extremely good strength is its unheard-of sensitivity to infrared light. In contrast to the Hubble Area Telescope, which excels in the ultraviolet and seen spectra, Webb's infrared sensors allow it to peer via clouds of interstellar dirt and discover the faintest of alerts from the earliest moments of the universe. With this advantage, JWST can appearance further again in time than ever earlier than, shooting glimpses of what the universe gave the impression of a mere few hundred million years after the Large Bang. However, instead of validating our contemporary models, those glimpses have exposed unexpected anomalies. The galaxies captured with the aid of Webb are extra-massive, greater-based, and appear a long way earlier than existing models could propose. It's as if complete galaxies formed at breakneck speeds immediately after the universe commenced. One of the most sudden factors of Webb's findings is the presence of mature, nicely shaped spiral galaxies at a time while the cosmos have to have been in its infancy. Traditional know-how indicates that young galaxies within the early universe would have abnormal, chaotic shapes due to the turbulence of cosmic formation. However, Webb's observations have time and again proven galaxies that resemble present-day spirals and elliptical galaxies, seemingly untouched by means of the violent methods that must have ruled their formation. The invention of those mature systems in a supposedly young universe has forged doubt on our understanding of galactic evolution, prompting scientists to revisit lengthy held assumptions. Such observations have fueled theories that the universe may have gone through speedy phases of evolution that we have yet to apprehend. Some scientists advise that darkish matter, an elusive substance notion to make up an enormous part of the universe's mass, may have played a key role in this vast improvement. Darkish depend is invisible, detectable simplest through its gravitational effects, yet it may have acted as a scaffold, shaping galaxies and clusters at outstanding speeds. This speculation, even though compelling, opens up new questions about the character of dark count number itself and whether it could give an explanation for the fast emergence of these primordial galaxies. But the mysteries don't give up with galaxy formation. Webb has additionally exposed unexpected details about black holes, particularly supermassive black holes located at the centers of historical galaxies. Those black holes appear a ways larger than they must be, given the teenagers of the cosmos at the time they existed. In principle, black holes develop with the aid of accumulating be counted over the years. Yet Webb has found supermassive black holes in the early universe that defy this slow increase version. How ought to such massive structures form so fast? A few scientists speculate that those ancient black holes can be remnants from a previous universe or formed through processes we haven't yet theorized. One radical concept gaining traction is referred to as conformal cyclic cosmology, CCC, championed by means of Nobel laureate Roger Penrose. In step with CCC, our universe is just one in an infinite sequence of eons, with each eon finishing in a new large bang that gives start to the following universe. If real, this model might suggest that positive structures like supermassive black holes might live on the transition among universes, wearing over statistics or power from one cosmic cycle to some other. Webb's discoveries of historical large black holes lend interesting, if circumstantial, help to CCC. If those black holes are certainly remnants from a preceding eon, it may explain their mysterious length and presence so early in our universe's records. Webb's latest findings additionally task the conventional idea of cosmic inflation, a theory that posits the universe underwent an exponentially fast expansion right away following the massive bang. This inflationary period is thought to have smoothed out the universe, creating an enormously uniform cosmic backdrop against which galaxies and other systems would later form. However, Webb's observations of abruptly mature galaxies appear to contradict this era of smooth, uniform expansion. A few researchers now question whether or not inflation came about as we apprehend it, or if opportunity processes should account for the universe's present structure. The revelations about the early universe's shape additionally cause broader philosophical questions. May want to the universe itself be countless, each in space and in time? Are we witnessing the earliest tiers of an endless cycle of introduction and destruction? Webb's findings advise a miles richer, greater complex narrative than the only we have been taught. The cosmic panorama can be massively older and a long way greater mysterious than formerly imagined. As scientists hold to analyze Webb's data, we're compelled to confront the possibility that everything we knew about the universe's origins and evolution is probably incorrect. That is an exciting and humbling attention, one that highlights the electricity of science to continuously push past the boundaries of our know-how. The universe may be a long way stranger and older than we ever dared to imagine, and the answers to the most profound questions can also lie simply past the reach of our cutting-edge understanding. With every new revelation, the James Webb Space Telescope is rewriting the tale of the cosmos, and in doing so, it is starting the door to new possibilities, new mysteries, and new beginnings.